Okay, so what we're going to look at on this is how to tell if functions are increasing or decreasing. Okay, and a function is going to be increasing wherever the derivative is positive, and it's going to be decreasing wherever the derivative is negative. Okay, so I want to kind of show you, we're going to do sign charts. So if that sign chart didn't make sense on that last problem, this will help you with that too. Okay, so the idea is going to be this. Now, so if you look at this diagram, I just took this off the internet. Okay, you're increasing from there to there. Increasing just means if you go from left to right, the y values are getting bigger, right? Okay, this area here you would call constant because the y values are not changing. Then you would be increasing again, then decreasing. So what kind of a tangent line, remember a derivative is the slope of a tangent line. What is the slope of a tangent line like right there?
Positive.
Positive, exactly. That's what you need to understand is whenever the tangent line's positive, that means the function's got to be increasing. What happens to the tangent line when you're decreasing? It's negative, exactly. So, and how about constant? What kind of a?
Zero.
Yeah, the zero slope, okay? So like if you look at this diagram right here, you've got basically, you're increasing until you get there. Then you're decreasing until you get there, then you're increasing again like this. So one of the things I want you to do is see a sign chart is going to tell you that. Right here, the derivative is going to be positive. Okay, so when you're below that, when you're below -1, the slope of those tangent lines is positive. Everybody understand that, okay? Okay, then you're going to be decreasing. So what happens there? The tangent lines have negative values. Then you start increasing again, so you have positive values like that. So one thing that you want to do is, we're going to do sign charts with derivatives, and what you would say about this graph right here is you would say that you're increasing from -infinity to -1, and so you're naming this interval with an x value. Then you're decreasing from -1 to 1, because the derivative's negative, and then from 1 and beyond, you're increasing like that. So the sign chart is going to tell you this. It's going to tell you the function's increasing, then it's decreasing, then it's increasing again like that. Okay, does that make sense to everybody? Okay, all right. So increasing, you're always reading from left to right when you're looking at this too. Okay, those are the possibilities. Okay, another thing that we're going to kind of define here is a critical number. What that is you look at where the derivative is 0 or where the derivative is undefined. So a lot of times I have you find critical numbers, and that's how you do an analysis of where functions are increasing and decreasing and where there's maximums and minimums, okay? So the idea of what you want to get established right now is you're increasing when the derivative is positive, decreasing when the derivative is 0, or I'm sorry, it's less than 0, and so forth, okay? All right, so the first thing I want to kind of do on here is we're going to look at just graphs and identifying things. Okay, so let's take a look at this graph. I took this out of the book. We're going to look at where we have minimums and maximums. Okay, so first of all, what a local minimum is that's going to be some place where the graph changes directions. So it's going to go like decreasing, and then it's going to turn around and increase. Okay, that's what a local minimum is. All right, so one local minimum would be here because the graph is decreasing and then it increases like that. So C2 would be a minimum, okay? There's another minimum. Where's another place where the graph decreases, then changes directions? Right there. That would be another one. Again, you're decreasing and then you change directions and you're increasing. So also C4 would be a minimum like that. Is there any other place on this graph where the function does that? Decreases, hits a low point, then changes directions. Now you got to be careful about that. Yeah, that what should be it. Now right there, the derivative is 0, but you're decreasing and then decreasing more. Okay, so you have to change directions when you do that then. So that would be the only place where you find a local minimum. So a local maximum is just the opposite of that. The graph has to change from increasing to decreasing. So you want to look at places on the graph on this where you change from increase to decrease. Okay, where does that happen? C3? So C3 is a good place, so you're increasing. Then you start decreasing when you get to that high point. Okay, so the C3 would be one. Any other place? C6, good. Okay, any other place?
C5 count?
No. Okay, and here's what happens at C5. You're increasing, right? Then you just level off just for 1 point, and then you're still increasing. So it's got to change from increase to decrease. It's like you're on a roller coaster. You hit the high point, and then you're getting ready to go down the big ride. Okay, like that. Okay, now, so we have that. All right, now we need to identify every place on here where the derivative is 0. So you're looking at a place where the tangent line's horizontal. Well, that happens lots of places. It happens there at C1. It happens at C2. It happens at C3. What happens at C4? We talked about that. Sharp point, what does that tell you? It's not differentiable, so there's no derivative there. There's no derivative there. Next place would be C5. Okay, how about C6? Sharp point? No derivative. Okay, we've talked about that. C7, anything happening there? It's a sharp point, really, it's no derivative. So those would be the places on that. And the thing I want you to notice is just because a derivative is 0 does not mean that it's a minimum or a maximum. Right there, that is not a min or a max. You agree? But the derivative is 0, right? The other place I think I heard you asking about that was this. Okay, the derivative is definitely 0, but it's not a max or min because it doesn't change directions. Okay, that's the idea. Okay? All right, now let's look at kind of figuring out everything on this graph then. Okay, so let's look at where this is increasing and decreasing. So I'm just going to highlight where these things change. So right now, from there to there, what's it doing? It's decreasing. Okay, so we got that. Okay, now the next place, what's it doing from there to there? Now it's going to increase. Okay, and then the next thing from here to here, what's it doing? Decreasing. Okay, just think like a roller coaster. And then finally, from there to forever, it's going to be increasing like that. So it's easy to identify that from the graph. Now, when you do intervals, you always want to use x values. That's real important. So if I want you to give me an interval where you're increasing and decreasing, you write interval notation, but you do x values. Okay, so increasing, that would be what I highlighted in blue. Where is it from? 1 to 3. Good. And then union 4 to infinity. Now, like on my math lab, I don't know if they'll make you do the union. That's usually what I do, is have a union. Sometimes you can just put a semicolon on there, but I think the best way is to do a union on there, and they'll have a union symbol. What's that? Yeah, I think you have to get that U on I think on the toolbar. Okay? Where's it decreasing? Negative infinity until 1, and then where else? 3 to 4. And by the way, you always use parentheses. That's another important thing. If I'm having you name intervals where you increase and decrease, they're always open intervals. That's important because the point like at 1, the derivative is equal to 0. Okay, so it's kind of neutral. It's not considered increasing or decreasing. Okay? All right, now where would be a minimum, a local minimum? Remember, a minimum, what does it mean? You decrease, then you change directions and increase. Okay, right there and right there. Now you're going to give the points. I say give the coordinates, so that looks like 1, -1, and 4, just estimate. Let's just say 0.5. It's probably not 0.5, but that's good enough. So you'd have a min there and a min there. So one of that is 1, -1. The other one is, what do you think, 4? How about 0.6? Okay, just whatever. Okay, like that, just estimate. Okay? All right, the next one was supposed to say maximums. That's a misprint on my part. So do you have a local maximum?
3.
Yeah, at 3,1. Okay, all right, so that would be your max right there. So you have a local max at 3,1, that's it. Okay? Now, the next thing you want to kind of look at is, okay, where is the derivative greater than 0? Well, trying to get you to make a connection here. Right now, the derivative is what? Negative. Then what?
Positive.
0, then what? Positive, 0, negative, 0, positive. Everybody see what I mean there? It's the slope of a tangent line. So basically you would be, the derivative would be greater than wherever you're increasing. We already answered that. So it's the same answer as we had on number 1. So that would be from 1 to 3 and from 4 to infinity. Okay, that's not a trick question. I want you to know that 1 and 5 are asking the same thing, really. Okay, and then how about the derivative negative? That means you're decreasing. So that means that's the same as what we got on problem number 2, which would be negative infinity to 1, union 3 to 4 like that. Okay, that's it. Okay, and how many places is the derivative equal to 0? 3. So we're going to put the coordinates on that. We'd have 1, negative 1. Okay, and then we'd also have 3, is that 3, 1? That looks like 3, 1. Okay, and then the other place where the derivative is 0, let's just say 4.6 or something like that. I'm just estimating on that. Okay, so that's one of the first things you want to know how to do is just look at a graph, figure out those intervals and where the local max and mins are. Okay. Okay, let's do one other one here, then I'm going to let you guys probably do one, and I'll probably fit about all of we'll have time to do. It's just kind of introduce the idea today. Okay, so let's look at kind of what happens on this one. So I'm going to just highlight where you're increasing. So we're going to increase from there to there, it looks like, and you're going to be increasing from there to there. Okay, the other places it looks like you are decreasing. Now this graph does not go on forever, so it's not going to have an infinity in it. So if you do increasing, then be sure that you use x values. So that looks like increasing from where to where? Negative 7 to negative 1. So we just say negative 7, negative 1. And where's the other place? 1 to 3. Okay, so we got that. Okay, decreasing, where's that going to be? Negative 1 to 1. Remember, use x values. And where else? 3 to 7. Now, we're not going on forever. We are stopping. This graph has a definite beginning and a definite end like that. What's that?
It's not technically decreasing from 5 to 7.
Oh, hold on. I didn't see that last thing there. I wasn't paying attention. Yeah, okay, it would be 3 to 5. Now, what happens from 5 to 7?
0.
Okay, you have a 0 slope. We say that's constant. Okay, so you might make a note from that. So that would be 3 to 5, like that. Okay, now see, we'd also have constant. I didn't give a blank for that, but constant would be 5 to 7. Okay, everybody understand that? Constant just means it's perfectly flat. It's not increasing or decreasing. Okay, does this have any local minimums? How many? 1. Okay, an end point is never a local minimum, and that's a good thing to write down, is an end point is not, and we're talking about what we call a local min or a local max. Okay, it's not endpoints, because remember what a minimum is the graph has to go from decreasing to increasing. It's got to have something going on the left and something going on the right. So the only min would be there. So if I wanted the coordinate of that, that looks like the point 1, 2. Okay, how many local maximums does this have? 2. Okay, there's a max there. Okay, again, the graph changes from increasing to decreasing. There's also a max there. So that looks like that's going to be, what, negative 1, 4. And the other one is, what, 3, 5. Okay, like that. Okay?
So on increasing and decreasing, you're only listing the x values,
yes.
And then the coordinates of the minimums and maximums.
You're given a point. That's not an interval. Yeah, so if I want a coordinate, that's not an interval. Okay? Okay, what does number 5 mean? Increasing. Exactly. This is the same thing as increasing. This is saying, where is the tangent line positive? Well, that means where it's increasing. So you could just rewrite the same answer as we got on number 1. Okay, I want you to know that. Okay, what does problem number 6 really say?
Decreasing.
Where are we decreasing? Okay, so that would be the same as problem number 2. So we got negative 1, 1, 3, 5, like that. Okay. All right, now let's find every place where the derivative is 0. That's a good question. What do you think? It's got to be a tangent lines like this. Okay. How about there? What's the deal with that? That's a sharp point. So what is that? The derivative does not exist there. Same thing there. The derivative does not exist. You can't draw a tangent line there. You can't. Okay. It can be all kinds of ways. How about right there?
Yeah.
So actually you would have, the derivative would be 0 from 4 to 7. It would be every point from 5 to 7. So you would actually write this like this, and it wouldn't be coordinates. You couldn't do coordinates. You would have to do an interval. So the interval would be, now 5 you would have to, like that. Then you would go to 7 like that. Now what you would do on that is you would have to have a bracket on the 7, and you could also, that's probably a sharp point because it's going from a line to a curve, so you would have a parenthesis there. That's kind of a technical detail there, but that's what would happen. Because you definitely have a tangent line right there of 0. That one's probably a parenthesis. Okay, now how many places would there be on this graph where the derivative doesn't exist? You're looking for sharp points.
3.
Careful. 1, 2, 3. Probably there. Okay. That again, what you have is you have a line and a curve. That one's kind of hard to see, but that one would also be considered a sharp point. So what you would have for your coordinates on this would be this. It looks like you would have negative 1, 4. And then you would have definitely 1, 2. And let's see, 3, 5. And then that one's the one that's kind of tricky, is 5 and 1. Okay, if you have like a line and a curve, it's a sharp point. Doesn't look like one, but it is one. Okay, sharp points don't have to be like a perfect arrow or something. It's just where you have something, two functions or totally different functions are joining in some way like that. Okay. Okay, so that'll wrap us up today and bring us and